In this video tutorial, we are going to customize a mind mapping client-server application that uses the MindFusion diagramming library for JavaScript. The initial project can be downloaded from MindFusion's GitHub account. Here it is. We clone it into an empty folder. This project uses Vite for the frontend and a Node.js server for the backend. Let's install the required packages by running npm install. To run our project, we need to open two terminals. In the first, we'll run node server.js to start our backend. In the second, we'll run npm run dev to start the Vite development server for our frontend. Thanks to a proxy we've set up in the Vite configuration, our frontend will be able to communicate with our backend server. And here's the application. When a client connects on the provided URL, whatever they change is broadcast to the server and then to all other clients. This is the final version of the enhanced application we're aiming for. We have added the option to choose text. Note, in link color, remove head shapes for links, move shapes to the bottom, and specify the thickness of links. The final app also loads a beautiful diagram from a JSON file when started. Let's start by surveying the initial application. First, the web page, index.html. It contains several canvas elements required by the diagram, overview, and zoom controls. The ruler and the palette are rendered by div elements. Let's look at the server side now. In server.js, we import the necessary packages for our Express server, socket.io, and MindFusion diagramming. The code creates a simple Express server and attaches a socket.io instance. We also create a server-side diagram instance that keeps the master copy of our diagram state. Once a user connects, we emit a load event, which sends the current diagram as a JSON string to that new client. The server includes various socket.io event listeners that listen for diagram events like node created, node modified, link created, link text edited, and more. The event data contains the necessary info regarding the action, and the server promptly broadcasts the change to all other connected clients. Now, let's look at the client side in index.js. First, we import all necessary classes, which are similar to those for the server. Then we create a diagram view. The server didn't have to render a diagram, so it only needed a diagram instance. Clients need a diagram view to handle the drawing. Then we add some styling for nodes and initialize the palette control. The palette holds instances of various nodes that the user can drag and drop onto the diagram. If you are curious about all the events the diagram offers, you can check the extensive online documentation, where all events are listed with their respective data. The client code handles events in a two-way process. First, when a user makes a change, the diagram raises an event, like node created. We listen for this, package up the necessary data, and emit it to the server via socket.io. The client also contains listeners for events broadcast from the server, which it uses to draw the changes made by other users. And with that, we have finished surveying the initial project. Let's look now into its enhanced version and see how the new features were added. The new version has a panel with styling options. So, the web page has new HTML controls. The color pickers are traditional input controls with their type set to color. To handle these new features, we introduced a versatile item modified event. This works alongside the existing events like node created, but it's perfect for handling property changes on existing items. For example, our new color pickers have event listeners attached. Inside, we get the new color and emit the item modified event to the server, sending a payload like ID, some node ID, text color, red. On the server, a single listener for item modified can now handle updates for text color, background color, z-index, and more before broadcasting the change to everyone else. The Move to Back button uses this same event, calculating the lowest z-index on the diagram and emitting the change. The palette control has been updated with different shapes. You can customize this by looking at the predefined shapes table in the documentation. Each shape is mapped to a string, so you can simply assign the name as the node's shape property. Now, for the last part. How do we load a ready diagram from a JSON file? As you see, users can export their diagram as a JSON file using the Save button. Once we've created a mind map we like, we save it as diagram.json and place it in our project folder. To load it automatically, we created a simple API endpoint in server.js. This endpoint reads the diagram.json file. In index.js, when the page loads, we fetch from this endpoint. It's important to note that diagram.fromJSON expects the file's content as a string, not the file name. Our code reads the file on the server and sends that content string to the client. The client then passes that string into diagram.fromJSON to load the diagram data. And this is the end of this video tutorial. We've just walked you through the process of creating a fully functional, collaborative mind mapping application. Thank you for watching, and thank you for your interest in MindFusion developer tools.